when divided by x minus 3, the polynomials x cubed minus px squared plus x plus 6 and 2x cubed minus x squared minus in the bracket p plus 3 into x minus 6 leave the same remainder. Find the value of p. Right. So in this, and question was asked in the ICSE 2010 examination, quite old, I see. So the first thing that you want to notice here is we've got two polynomials this time, unlike in the usual sums where we have just one. So let's consider our first polynomial as f of x, right, which is equal to x cubed minus px square plus x plus 6, right? And let's consider our second polynomial as g of x, because one is f of x, the other one can be taken as g of x, which is 2x cubed minus x square minus, in the bracket I have p, plus 3 into x minus 6, right? So if there are two polynomials like that, we can consider one to be f of x, the other one to be g of x. Can't use the same variable name, function name for both of them, right? Now we have one common divisor, which is x minus 3. So remember remainder theorem, we say let the divisor, which is x minus 3, we equate that to be 0. And from this, I get the value of x as 3. Now understand the remainder. In both the cases, they have given us one point over here, that they leave the same remainder on division by x minus 3, right? Since both of the polynomials on division by x minus 3, right, we know that the remainder is the same. So I can say remainders are equal, correct? So the remainder in the case of the polynomial f of x, remember, would be f of 3, right? And the remainder in the case of g of x would be g of 3, right? And according to the given condition that the remainders are equal, that means f of 3 should be equal to g of 3. Yeah, and this basically is going to be my equation with only p as the only unknown, and I should be able to solve it. So f of 3 is basically 3 in place of x in the f of x equation. So x cubed becomes 3 cubed minus px square, so p, right, and x square is 3 square plus x, which is basically 3, and plus 6, right? And this is equal to g of 3, which is basically just 3 instead everywhere in the g of x polynomial. So 2 times x cubed, which becomes 2 times 3 cubed, minus x squared becomes 3 square minus p plus 3, so p plus 3 times x, so x is again 3, and minus 6 at the end. Okay, so as you can see, we have one equation where the only unknown for us is p. If I am to solve this equation, I should get the value of p, so let's do just that. Let's try to solve this equation. So 3 cubed is 27, minus p into 3 square, so 3 square is 9, so p into 3 square will make it 9p, plus 3 plus 6, right? So plus 3 plus 6 is equal to 2 into 3 cubed, 27 into 2 is 54, minus 3 square, which is 9, minus multiplying the 3 inside, so 3p minus 3p, and minus 3 into 3 will give me minus 9, and minus 6 at the end. All right. Let's simplify this a little further. 27 plus 3 is 30, 30 plus 6 is 36, so therefore I can say 36 minus 9p is equal to 54 minus 9 is 45, minus 9 is 36, minus 6 is 30 is equal to 30 minus 3p. Alright, let's just rearrange our terms now. Bring all the p terms on one side of the equation and the other is on the other. So take 3 to this side and let's take 36 to the other side. So I have minus 9p plus 3p is equal to 30 minus 36. Right, so minus 9p, almost at the final answer now. Minus 9p plus 3p will make it minus 6p, and 30 minus 36 makes it minus 6. So minus 6p is equal to minus 6. Therefore, I can say p is equal to 1. This here is my final answer.